Dear participants of the conference, I present the topic of article to your attention. Sustainable modified pozzolanic supplementary cementitious material containing fly ash, natural zeolite, and silica fume. An important problem, according to the priority areas of the European Green Deal, is ensuring carbon neutrality, introducing innovation, modernization, and greening of industry. According to the low carbon development strategy, it is necessary to reduce carbon dioxide emission at every stage of the production and technology obtained for the production of clinker, cement, and concrete to construction. Already by 2030, it is planned to reduce CO2 emission during the production of cement by 30% and the stage of concrete production and construction by 40%. And investigation task of the article is to create eco-efficient blends containing supplementary materials, to design criteria hydraulic interface activity of supplementary cementitious materials to show technological, technical, economical, and ecological benefits from using supplementary cementitious materials in low carbon concrete. The solving problem of energy efficiency and reducing CO2 emission in building production is largely determined by set of more ecological ways to replace a part of Portland cement clinker with supplementary cementitious materials. Due to the rational selection of cementitious materials in the production of low-carbon cement, technical, ecological, and economic effects are achieved. Pozzolanic supplementary materials such as natural zeolite, fly ash, and microsilica were used. Adding supplementary cementitious material pozzolanic action directly to the concrete mix instead of part of the Portland cement contribute to reducing the cost of concrete, increasing the strength in subsequent period of hardening and increasing durability. In this case, replacing each kilogram of clinker in concrete with additional cementitious materials allows reducing CO2 emission by 0.61 kilogram. Fly ash is an important pozzolanic materials when mixed with cement significantly affects the strength development of the cementitious composites. Fly ash increases durability and strength of concrete at later age, but at the same time reduce the early strength of concrete. It also reduces the amount of the water reducing admixture just required to obtain the same consistency. Silica fume significantly increases the strength and durability of concrete, but it has a high water demand, so it requires the use of increased amount of water reducing admixture. Significant resource of the European region of natural porcelain is zeolite tools. This makes it possible to solve the problem of regional application of pozzolanic supplementary cementitious material. Highly seasoned zeolite tools, the main mineral of which is kropyvnytska, have unique characteristics such as high specific surface area and ability to extend cation. Natural zeolite with 70% CO2 provided from Kropyvnytska quarry was used. Superfine zeolite was obtained by grinding natural zeolite to specific surface area greater than 11,000 cm² per gram. Interaction of superpozzolana with products of hydration porcelain clinker lead to decrease its porosity, which help to increase the strength, corrosion resistance, and determine its durability. According to the European standard, the strength activity index after 28 days should be more than 75%, and after 90 days, more than 85 acids. As can be seen from the slide, super zeolite and microsilica react the corresponding indicator already after 2 days of hardening. The strength activity if index of fly ash meets the requirements of European standard, but is significantly lower compared to superfine zeolite and microsilica. Highly dispersed supplementary cementitious materials as superfine zeolite and microsilica are characterized increased water demand and have low bleeding. Fly ash is lower dispersion compared to the other pozzolanic materials. Fly ash is characterized by particles of the correct spherical shape, which provide a plasticized effect due to the roller-bearing effect. Therefore, its water demand is reduced 27%, but it's characterized by significant bleeding. The optimal composition of complex pozzolanic materials blends are determined by strength activity index. The combined effect of component on the pozzolanic activity after 28 and 90 days was investigated using the Schaeffer simplex electric plant method. For the component mixture, each point of the triangular diagram corresponds to one ratio. The regression equation is presented as follows. The optimal composition of the combined pozzolanic activity fly ash is 60% superfine zeolite, 30% and microsilica 10%. Significant reserves of improved physical technical properties of blends, 50% of supplementary cementitious material and 50% of CEM1 are achieved due to the use of lignosulfonate and polycarboxylate plasticization admixture. As can be seen from the table, when introducing 1% of polycarboxylate, the flow ability of standard cone increased from 144 to 290 millimeter, and when lignosulfonate was used, it increased only to 225 millimeter. The water-reducing effect for the lignosulfate modifier is 14%, and when modified with polycarboxylate, water-reducing effect is 22%. At the same time, the blend modified with polycarboxylate is characterized by higher compressive strength. More than 20 megapascal after 2 days and more than 50 megapascal after 28 days. When using complex pozzolanic cementitious materials, optimization of the properties of binder is ensured. Workability, standard, and early strength, durability, cost, impact on the environment. The conclusions of this article are present in this slide. Thank you for your attention.